Okay, in this video we're going to talk about finding inverses of functions. So to do that, we follow a basic procedure. First thing you want to do is you want to change f of x into y if you need to. So a lot of times you start out with y equals something. Other times you start out with f of x equals something. It's much easier if you just change f of x into y right off the bat. So the next thing you want to do is you're actually going to switch x and y. We're going to do some examples, but that literally means switch x and y. So every y becomes an x, every x becomes a y. And then the next thing you do is you're going to go through and solve for y. Sometimes that's easy, sometimes it's a little more challenging, and we're going to do examples of both. And then finally, you're going to replace y with f inverse of x if you're using function notation. So f inverse of x is maybe the most confusing notation that you've run into. That little, what seems to be an exponent of -1 is not an exponent. It's telling you that is the inverse. It's confusing, but you have to get used to it because it's not going to go away. So let's do a bunch of examples. So if we start with f of x is 3x plus 2. So we're just going to follow the steps. I'm going to replace f of x with y. And then I'm going to switch x and y. And now I'm going to solve for y. So subtract 2, and then divide by 3. And then I'm going to go back and replace y with f inverse. So f inverse of x is 1/3 the quantity x minus 2. Let's do another one that's like that. So f of x is 2 plus 1/4 the quantity x minus 3. So replace f of x. And now I'm going to switch x and y. So I get this. So I'm going to subtract 2. I'm going to multiply both sides by 4. Don't forget parentheses there. I'm going to add 3. So 4, the quantity x minus 2, and then plus 3. And then I'm going to replace y with f inverse. Okay, so these are about as basic as it gets. We're really just finding the inverse of a line, right? Those were linear functions. So I didn't need to worry about anything. The next problem I'm going to need to worry about something. So if you notice, what we're doing is we're switching x and y. If you switch x and y, a relationship develops. So the relationship is first, the domain of f of x, so the original, becomes the range of f inverse because we switched x and y. And then another thing, the range of f of x is going to become the domain of f inverse of x. And again, that's because we switched x and y. That second one is actually really important, and we have to keep track of that. And now we're going to do an example where that really matters. It didn't matter in the previous ones because the domain and range were all reals. So this really is only going to kind of bite you if the domain or range are not all reals. So here's one where that is the case. So we have f of x is radical x minus 3 and then plus 1. So looking at that, just by inspection and what I know the domain is x is greater than or equal to 3, and I know that the range is y is greater than or equal to 1. So that's the domain and range of f of x. So that's going to impact f inverse. So let's find the inverse. So y is equal to radical x minus 3 plus 1, so I switch f of x to y. I'm going to swap x and y. So x is radical y minus 3 plus 1. Subtract 1. And now I'm going to square both sides. So solving a radical equation now. Square both sides. And then add 3. And then I'm going to switch y with f inverse. So f inverse of x should be the quantity x minus 1 squared plus 3. But now remember, the range of the original was y is greater than or equal to 1, which means the domain of my inverse function is x is greater than or equal to 1. So that's a case where it really matters. So you have to keep track of that because if I give you values to plug into the function, into the inverse I should say, you have to make sure that those values are actually in the domain of the inverse before you even evaluate them. Because if they're not in the domain of the inverse, it doesn't make any sense to evaluate it there. So that's a good example of where that happens. We're going to do one more example of a function where it's kind of challenging to find the inverse, but the inverse definitely exists. So I have f of x is x plus 3 over x minus 4. Just going to follow the steps, but it's a little more complicated algebraically, and I think that's probably the issue. So I replace f of x with y, swap x and y. Now you notice I have two y's, and they're in the numerator and denominator of a fraction. So I'm going to solve this by cross multiplying. So cross multiply. So I have x, the quantity y minus 4 equals y plus 3. Now on the left hand side I'm going to distribute. So I get this, so distribute x to everything. Now what I want to do is get everything with a y on one side and everything with an x on one side, or rather everything that doesn't have a y on one side. So first I add 4x to both sides. Now I'm going to subtract y from both sides. Now I'm going to move up to the top here, and I'm going to factor y out of everything on the left-hand side. And I'm going to divide through by x minus 1. Get that? And so I've solved for y, so I'm going to replace y with f inverse. And I'm going to put a box around it, and I'm done. Okay, so that's how we can find the inverse of a function. There's a couple things you need to watch out for. Domain and range in particular, so that you make sure you limit the domain of the inverse function. And also, don't give up just because the algebra gets a little complicated. I hope you found this helpful, and good luck.